Good evening, everyone.
Good evening, sir.
Yeah.
Good evening, sir.
Okay. Let's start this task. So I welcome you to all for the second. Let me see. Someone has written. Uh, so please resolve assignment of week one and week two. Yeah, week one assignment will be released. I think by Monday, and week two will be released after next week. Next week. Because after the both the problem solving sessions are over, then only they will release the result answer sheets. Is it fine? Okay, so let's start the today's class. So I welcome you all in the second week of this problem solving session related to structural analysis course. Let me share my screen first. I hope the screen is visible to everyone. Can anyone confirm?
Yes, sir. Visible answer.
Okay. So this is your week two regarding structure analysis course. Let me introduce myself. My name is Pranam Mahajan. I am a PMRF scholar in Structural Engineering Division from Department of Civil Engineering in IIT Madras. So we are given the opportunity to help you in solving the problems related to what you have covered in the current week. This week we have covered topics related to trusses. So all the problems that will be covered in this session will be related to how the forces can be determined at different members in trusses. So this is your course layout. As we have discussed in previous session also, that till sixth week you will be covering the statically determinate structures, in which what you have covered in the previous week will be considered. Then today's week related to plane truss, how you will determine the forces for members using method of joints and method of sections. Then determining the deflections in trusses using method of virtual work. After that, we will move to beams and frames, in which we will determine the deflections using moment area method, conjugate beam method, and virtual work method. After that, we will solve the problems related to moving load method, like a train is moving over a bridge. Then what are the forces that are coming in that bridge? We will determine that. So that will come under influence line diagram. After that, this same course we will do for statically indeterminate structure. So by the time you must be knowing the difference between what is there in statically determinate structure and statically undeterminate structure, then only you can able to find out that how you can determine the forces in both the types of structures. So same we will do for statically indeterminate structures. We will do for beams, frames, as well as trusses. And same, they have different methods. They have a method of consistent deformations, moment distribution method, and slope deflection methods. Okay, so this is your course layout for this whole structure analysis course. So regarding what you have covered in week two, you have solved the problems related to statically determinate structures, which are trusses. You have solved the problems related to trusses by two methods. One is method of joint, another is method of sections. So if we try to define what is a truss, so truss is a two force member in which there is no bending moment, or we consider the bending moment to be equal to zero, because bending moment will definitely come in any member which are undergoing deformations. But In this, we consider to be equivalent to 0 because the length of the member is very large, due to which the shear force effect overpower them compared to bending moment that is occurring in the structure. So only difference by this time you have to remember is a truss is a two force member in which bending moment is equal to 0, whereas a beam is a member in which shear force as well as bending moment both will come into play. So that means your frame is also a member in which shear force as well as bending moment comes into pictures. Okay, so for the analysis of truss, you have two methods. One is method of joints, another is method of section. So how you solve the problems related to method of joints? You consider any joint, you apply equilibrium equations. So what are the equilibrium equations? You have summation of forces in horizontal direction equal to 0. You have summation of forces in vertical direction equal to 0. So these are the equilibrium equations that are defined for trusses. In general, we have three equilibrium equations which are like summation of forces in horizontal direction equal to 0, summation of forces in vertical direction equal to 0, and moment at any particular point which you are considering is also equal to 0. Okay, so this thing we will apply for method of section of method of joint. Regarding method of section, how you will solve the problem? You will cut the truss in such a way that three forces or more than three forces will come into picture, but this should be in such a manner that all the forces will be equal to 0, but only one unknown force will come into picture, and then only you will be able to solve the problem related to method of section. Method of section we generally utilize in which you have to solve the forces in a member, but the structure is very complex, in which you can't apply the method of joints, or method of joints becomes very lengthy to determine the forces at that particular member. So only in that questions you have to utilize method of sections. You can't decide that I will choose only one method and remember one method to solve the problem. You have to know both the methods, then only you can efficiently solve the problems related to trusses. So now let's start the first problem related to trusses. So this is a simple truss given to you. You have to determine the static indeterminacy and the stability of truss. So what is the criteria for stability of truss? So stability of truss is defined by when your degree of static indeterminacy is equal to 0, then you say the structure is just stable. When your degree of static indeterminacy is less than 0, you said it to be unstable. When your degree of static indeterminacy is greater than 0, then only you will say the truss is stable. But this should not be your criteria every time to judge the stability of the truss. So stability of the truss should not be, I will write that stability of truss should not be judged only by the above criteria. Okay, what happens that in certain cases you will find that degree of static indeterminacy is equal to 0 or greater than 0, then only the truss will be, then in that case also the truss is unstable. Why? Because the supports or the constraints that are provided at the ends, they are not able to restrict the loads that are acting over that member. In that particular cases the truss is unstable. So whenever you are trying to analyze the truss related to stability, you have to check by applying the load, that in which direction the truss will move, whether it will sustain at that particular location or it will collapse. So if it is collapsing, whether your degree of static indeterminacy is equal to 0 or not, then also you can say that truss is unstable. Now solving this problem, this is the simple problem for you. You have to determine the degree of static indeterminacy. So degree of static indeterminacy is a summation of internal indeterminacy plus external indeterminacy. So previous week we have seen how to determine external indeterminacy. That will be equal to number of reactions minus number of non-equilibrium equations. That means R minus 3. Okay. So in this case, how many reactions you have? One is this vertical reaction in this roller support, and one in this another roller support. So you have two reactions minus three equilibrium equations available with you. So your degree of external indeterminacy is equal to -1. Now talking about internal indeterminacy. So you have internal indeterminacy. So for truss, you have formula m plus r minus 2j. So how this formula came, I will not go into that intricacy, because you have also covered the lectures in which the lectures explain how this formula comes into play. Okay. So in this, how many members are there? 1, 2, 3, 4, and 5. So 5 number of members are there. Total number of equilibrium equations available with you is 3 minus 2 into number of joints. So 1, 2, 3, 4. Total 4 number of joints are there. So your 8 minus 8 equal to 0. So your internal indeterminacy is equal to 0. So your total static indeterminacy ds will be equal to dsi plus dse, in which your dsi comes equal to 0, whereas your dse is equal to -1. So your degree of static indeterminacy is -1. So therefore, truss is externally unstable and also overall unstable, because in this case your degree of static indeterminacy is less than 1. Okay. Let's solve another problem. This is the second problem related to determining the static indeterminacy. In this, how you will solve? Again, define degree of static indeterminacy to be summation of degree of internal indeterminacy plus degree of external indeterminacy. So in this case, your DSE will be equal to R minus 3. So what will be the R in this case? So there is a hinge. So you will be having two reactions here. You have roller. So you will be having one reaction here. So your total R here is 3 minus number of available equations, that are also 3. So your DSE will come out to be equal to 0. Now applying for internal indeterminacy. So your DSI will be equal to m plus r minus 2j. In this case, your total members are 1, 2, 3, 4, and 5. So 5 members are there. How many reactions are there? Total 3 reactions are there. Now twice of number of joints. So joints are 1, 2, 3, and 4. So again, your internal indeterminacy is coming out to be equal to 0. So your total indeterminacy will be summation of DSE plus DSI, that will be 0 plus 0 equal to 0. Therefore, truss is determinate and just stable. Okay, fine. Now let's move to another question. So this is your third question. Again, you have to find the degree of static indeterminacy. Assume the diagonal members are not connected to each other. That means no joint is present in these particular points. Okay, so you don't have to consider these points for joint conditions. So let's start. So your degree of static indeterminacy will be sum of external indeterminacy plus internal indeterminacy. We will define external indeterminacy by number of reactions minus 3, which will be number of equilibrium equations. So in this case, again, you are having hinge. So you will be having two unknown reactions here and one no unknown reaction in case of roller. So your total indeterminacy externally will be equal to 0. Now talking about internal indeterminacy, you will be having m plus r minus 2j. In this case, count the number of members. So your number of members will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So total number of members here are 11. R here is 3 minus twice the number of joints. So how many joints are here? 1, 2, 3, 4, 5, 6. Okay. So total 6 number of joints are here. Okay. That will become 14 minus 12 equal to 2. So your degree of static indeterminacy will become dSE plus dSi equal to 0 plus 2 equal to 2. Therefore, truss is indeterminate and stable. Truss is indeterminate of degree 2 and stable. Okay. Now let's move to another question. In this case, determine the static indeterminacy. So your ds will become dsi plus dse. That will be equal to, so now find dse. That will become r minus 3 equal to, so number of reactions here is one vertical reaction, one horizontal reaction for hinge, one vertical reaction for roller. So here r is 3. 3 minus 3 equal to 0. Now talking about internal indeterminacy, your dsi will be equal to m plus r minus 2j. That will become, how many members are here? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So total 9 members are there, plus 3 for reactions minus 2 into number of joints. So joints here are 1, 2, 3, 4, 5, and 6. So total 6 joints are there. That will become 12 minus 12 equal to 0. That means your ds will be equal to dsi plus dse. That will become 0 and 0 equal to 0. Therefore, truss is statically determinate. But in this case, you see, if you try to apply the load at the top point, the truss will move in the downward direction, leading to collapse of the internal structure that is already made. So, in this case, your truss will not be stable, your truss will be unstable. So, truss is statically determinate but unstable. Okay, so this is the condition I was telling you. So, in this case, your truss is statically determinate, but due to the geometry of the truss, this truss is not stable, this truss is unstable. So, next question is, how many independent equilibrium equations are required to be satisfied for static equilibrium of a plane truss? So, this is the simple question for you. So, how many equations are required? So, three equations are required for satisfying the static equilibrium of the plane truss. So, which are these equations? These are summation of forces in horizontal direction equal to 0. That means your right hand forces should be equal to left hand forces. Another is summation of forces in vertical direction is equal to 0. That means your upward force should be equal to downward force. Another is moment at any particular point, suppose z, will be equal to 0. So these are the three equations that are required to be satisfied so that your static equilibrium of the planar truss should be satisfied. Okay, so these are the simple problems related to what we have covered in determining the indeterminacy and the stability of the truss member. Now we will solve the problems related to determining the member force in different truss geometries. Okay, so this is the question which is provided to you, in which you are expected to determine the member force in member AD. So which is member AD? So this is your member AD. Now first what you will do, you will determine the external reaction forces. So this is your RA, this is your HA, this is your RB. So what I am assuming in this, that reaction forces in the upward direction, I am taking it to be positive, and the rightward forces in horizontal direction to be taken as positive. Okay, so now apply the three equations of equilibrium. We have summation of forces in horizontal direction equal to 0. That means HA plus 15 kilonewton that is applied horizontally is equal to 0. This will give you HA equal to minus 15 kilonewton. Okay, so from first equilibrium equation, we got to know that horizontal force at A joint is equal to 0. Now apply second equilibrium equations. Summation of force in vertical direction equal to 0. So what you will get? RA plus RB. So in this case, there is no vertical reaction. So that will be equal to 0. So now we have two unknowns, that is RA and RB. How we will determine? We will apply third equilibrium equation, which is summation of moment at any point. So I am considering point A to be equal to 0. Now take all the clockwise moment to be positive and anti-clockwise moment to be negative. So In this case, 15 into 8 minus RB into 4 will be equal to 0. So RB will be equal to 120 divided by 4. That will be equal to 30 kilonewton. So from this, one reaction you get, that is RB equal to 30 kilonewton. Now put it back in the above equation, that is RA and RB equal to 0. This will give you RA equal to minus 30 kilonewton. Okay. Now we know the external reactions in this whole truss. Now what we have to find is the member force AD. So how we'll do? We will use method of joints. So using method of joints, we will first take joint C, sorry, joint E. Why I'm taking joint E? Because it is easier to get the joint force EC and ED, because we have only two equilibrium equations available. If I start with member A, I have to determine three forces, that is AC, AD, and AB. But we have only two equations available, so we can't solve the problem. So that's why you have to see from which joint you have to start. So utilizing equations from joint C. So first draw the free body diagram of joint C. What you will get, in which I am taking all the member forces to be tensile. Okay. So this is your joint E. This is your force ED. See this diagram, how this member force ED is acting upon and how this member force EC is acting upon. Okay. Now what will be the angle between these two? I will determine first the angle. So tan theta will be equal to 4 divided by 8, because this is 4, this is 8, which I already know. Okay, that means 0.5. So theta will be equal to tan inverse 0.5, that will be equal to 26.57 degree. So this is my theta. Okay, now let's solve the problem. So in this, first I will apply summation of horizontal force equal to 0. That will give me FED sine theta plus 15 equal to 0. So from this, I will calculate FED equal to minus 15 upon sine theta. That will give me equal to minus 33.535 kilonewton. I think till this point, everything is clear. Let's move to solve another force member, that is FEC. So applying summation of vertical forces equal to 0, that will give you FED cos theta plus FEC equal to 0. So how you will calculate FEC? That will be equal to minus FED cos theta. That you already know how it will be. So this implies FEC will come out to be 30 kilonewton. You have to substitute all the values, then only you will come to know what is the value. So now FEC you have calculated. Now move to joint C. So at joint C, Draw the free body diagram. So this is how your joint C looks like. Okay. So in this is FCD, this is FCE, this is FCA. Okay. From this, what you will get, summation of vertical force is equal to, sorry, summation of horizontal force is equal to 0. That means your FCD will be equal to 0. Apply summation of vertical force is equal to 0. This will give you FCE minus FCA equal to 0. This implies your FCA is equal to minus 30, sorry, plus 30 kilo Newton. Fine. Now let's move to joint A. Okay. Now we can solve the problem because at joint A earlier there were three reactions. Now only two reactions are there because one reaction we have already calculated. So taking joint A, draw the free body diagram for this. So this is your FAD, this is your FAB, FAC. I am drawing the reaction forces based upon the convention we have considered. Okay. Now we have to find FAD. How we will find? Let this angle in between be equal to alpha. I will not solve alpha. Let's directly move in solving the problem. That is summation of vertical forces equal to 0. This will give you FAC plus FAD sine alpha equal to 30. Okay. Now your FAC is coming out to be 30 plus FAD sine alpha equal to 30. So rearranging the terms, what we will get? We will get FAD equal to 0. So this is how we will solve the problem. And we got FAD in this equal to 0. So this is how you will solve the problems related to method of joint. So let's solve another problem. In this, it is given to you, calculate the force in member DE and AE. So what we will do, we'll again use method of joints and try to determine the following member forces. So which members you have to determine? One is BE, another is AE. So these are the two members you have to determine. Starting with the step 1. So what is the step? First, we have to determine what will be the external reactions. So let this be RA, this be RB, and this be HA. So taking summation of horizontal forces equal to 0, what you will get? HA equal to 0. Now take summation of vertical forces equal to 0. You will get RA plus RB equal to 30 kilonewton. Fine. Now use third equation, that is moment about a point, that is MA equal to 0. Now taking clockwise moment to be positive, that is 30 into 6 minus RB into 4 equal to 0. So you will get RB equal to 180 upon 4. This implies your RB will be equal to 45 kilo Newton. Now you have two equations, RA plus RB equal to 30, and you already know the value of RA equal to 45. So solve this, you will get RB to be equal to minus 15 kilo Newton. Oh, sorry. I think okay, RB is 45, RA is minus 15. So RA plus 45 equal to 30. This will give you RA equal to minus 15 kilonewton. Fine. Now you have to solve the problem for AE and BE. Okay. We'll first go to joint C, because from there we will get two member forces and then we will proceed further. So taking joint C, now draw the free body diagram. This is how the free body diagram of joint C looks like. In this, we are taking all the outward joint members to be positive and this angle to be theta. Now, how we will calculate theta? So, theta will be equal to, how I will write, tan theta will be equal to BE upon BC. That will be equal to 3 upon 2. This will give you tan theta equal to 1.5. From this, we can calculate the value of theta, that is tan inverse 1.5. What you will get? You will get the value as 56.31 degree. Okay. Now utilize equilibrium equations. You will get, I will start with summation of vertical forces equal to 0. This will give me FCE sine theta minus 30 equal to 0. That means FCE is equal to 30 upon sine theta, and it will be equal to 36.055 kilo Newton. Fine. Now let's solve for FCB. So your FCB, how we will calculate? Summation of horizontal forces equal to 0. That will give you FCE cos theta plus FCB equal to 0. That is FCB will be equal to minus FCE cos theta. That will give you FCB equal to minus 20 kilo Newton. Now you have calculated FCB. Now take joint B. In joint B, you can see from the figure, two forces are collinear and one is perpendicular. Okay, so that means this is your B. So this will be FBA and FBC, and your perpendicular will be FBE. By this time, you have to know that when two forces are collinear, the perpendicular to that will be equal to zero. So I will use that force, vertical force is equal to zero also. So that means your FBE in this case will be equal to zero, and your other two forces will be equal. That means your summation of horizontal force equal to zero equal to FBA minus FBC equal to zero. This will give you FBA equal to FBC equal to minus 20 kilo Newton. Fine. Now, oh, I missed one thing here. I missed the reaction from force B. So one another thing will also come into picture here. That is the vertical force RB. So in this case, your VBE will not be equal to zero. Okay, this is wrong. So this implies FBE plus RB will be equal to zero. This will give you FBE equal to minus 45 kilonewton. Okay, this is one thing that I have done wrong. So now I have corrected it. So that means one force you already calculated, that is FBE. So now it is coming out to be negative, but we have assumed all forces to be to be tensile. So negative means your force is compressive. Fine. Now only one member you is left for your calculation purpose. That is your member AE. AE, na? I think it is AE. Yeah, you have to calculate now AE. Now again, calculate at joint A. So now taking joint A, now we will draw the free body diagram for joint A. What we will get? And one reaction force also. So if this is A, this will be FAB. This is FAE, and this is FAD. Now again you take this angle to be equal to alpha. Now how we will solve alpha? So tan alpha will be equal to, if this is alpha, it will be equal to BE upon AB. BE upon AB, that will be equal to 3 upon 4. This implies alpha is equal to tan inverse 0.75. So solve this. What you will get? Alpha equal to 36.87 degree. Fine. Now, if we take summation of horizontal force to be equal to 0, we will get FAE cos alpha plus FAB equal to 0. You already know the value of FAB. From previously, we have calculated FAB equal to minus 20 kilonewton. Okay, so substitute that value. You will get FAE equal to minus FAB upon cos alpha will be equal to 20 upon cos alpha. That will give you FAE equal to 25 kilonewton. Okay, now we have solved for both the forces, what we will get? So our solution is, mm, so our final solution is F B E equal to minus 45 kilonewton, which is compressive force, and your FAE is equal to 25 kilonewton, which is your tensile force. Fine. Now let's move to another question. So here another question says that you have to determine the number of null member forces. So what are null member forces? So null member forces are those in which the forces coming out are equal to zero. So how we will determine that? We have to see one basic principle, that is, if two forces are collinear to each other, any one force which is perpendicular to that will be equal to zero. This is the one basic feature you have to know, and that only the way you can easily solve and calculate the number of null member forces. Another way is totally lengthy procedure. You determine the member force at each and every member utilizing method of joints. So you can see how many joints are there in this figure. Then only you will be able to determine the number of unknown forces. But we will not do that. We will just see how we can easily determine the number of null member forces. Okay. So first of all, please see this diagram carefully. I will zooming it. I am zooming in this diagram. So in this, two forces are collinear. One is AC, another is CF. Okay. So two forces are collinear. That means the third force which is coming out in this member will be equal to zero. Okay. So I have made one member to be equal to zero here. Secondly, move to joint P. Now again move to joint P. You have two members. One is AP, another is PO, which are collinear to each other. In this, the third member, that is PF, what it will become? It will again become equal to zero. Okay. Now since PF is become equal to zero, now again go to joint F. In this, member FC and FG are collinear, and your OF then will become equal to zero. Fine. Now we will move to joint N. So in joint N again, you have force NO and force NJ equal to zero. That will make your NQ equal to zero. Since your NQ is equal to zero, now move to joint Q. What you will get? Force NQ and force QJ are equal. Then your member OQ will become equal to zero. Okay. This is how we will move. Now we will find in another member. Now let's move at the center. At joint D, you will get the member here as DF, DG, and DH, which are collinear to each other. So third force here, that is member JD, will become equal to zero. So half of the truss we have now analyzed. Now remaining half truss we will start from right hand side. So how we will go? We will start from joint E. We will see that what happened. Okay. So we will see that force E I and force EB are collinear, that will make member ME equal to 0. Again, now take joint M. You have force ML and force MB to be collinear. That will make member MI to be equal to 0. Now move to joint K. In joint K, you will see the force KJ and KL to be collinear. Then your force member RK will be equal to 0. Now analyze joint R. What you will see that force Rj and Rh are collinear. That will make your member RL to be equal to 0. So now I won't be able to find any other force in this whole truss which is equal to 0. Now let's count the total number of force member in which the forces are coming out to be equal to 0. So this is first, second, third, fourth, fifth, sixth. Sorry, this will be sixth, 7, 8, 9, and 10. Okay, fine. Yeah. Anyone raise a hand?
Yes, sir. My name is Rajdeep.
Yes, tell me.
सर ये मैं हिंदी में बात कर सकूँ?
हाँ 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 हाँ, कोई बात नहीं.
सर ये जो मेंबर एल एच है ये भी मतलब जीरो हो जाएगा ना?
LH, जस्ट
एच
LH नहीं होगा. LH 0 क्यों नहीं होगा? क्योंकि उस पॉइंट पे अगर आप देखोगे, एक सेकंड मुझे फिर से उसको, हाँ, LH क्यों नहीं 0 होगा? अगर आप देखोगे यहाँ पे होगा क्या, आप जॉइंट आई तो देखो. अगर आप जॉइंट आई तो देखोगे तो उससे आपको पता चलेगा कि एल आई जो फोर्स है वो इक्वल हो जाएगा 20 किलो न्यूटन के, क्योंकि यहाँ पे फोर्स लग रहा है. ठीक है, अगर एल आई इक्वल टू 20 किलो न्यूटन हो जाएगा. अब अगर आप ये फोर्स देखोगे तो इसमें अगर मैं यहाँ पे समेशन ऑफ वर्टिकल फोर्सेस इक्वल टू 0 करता हूँ तो क्या होगा, एफ एल आई प्लस ये जो भी एंगल होगा, ठीक है, एल एफ एल एच cos थीटा विल बी इक्वल टू 0. सो आपका एफ एल एच जो होगा वो होगा -20/cos थीटा. वो 0 नहीं होगा. वो वो आपका दूसरी साइड 0 इसलिए आया क्योंकि वहां पे कोई वर्टिकल फोर्स नहीं था. अगर आप देखोगे ध्यान से, ये ट्रस सिमेट्रिकल है बट इसमें फोर्सेस सिमेट्रिकल नहीं है, जिसके कारण आपका जो एल एच मेंबर होगा वो 0 नहीं होगा. फाइन.
यस सर.
अगर कोई डाउट है आप पूछ सकते हो, अभी मैं फिर से बता सकता हूँ.
सर बट जो मेंबर आर डीजे है
मेंबर डीजे, हाँ हाँ,
उसके ऊपर मतलब जो 40 किलो न्यूटन का लोड लग रहा है तो फिर वो क्यों जीरो नहीं हुआ मतलब?
वो 0 इसलिए नहीं हुआ क्योंकि वो इक्वली डिस्ट्रीब्यूट हो जाएगा इस फोर्स मेंबर पे और इस फोर्स मेंबर पे. ठीक है, वो इधर डिस्ट्रीब्यूट हो जाएगा. बट ये वाला फोर्स मेंबर अगर आप जॉइंट डी से देखो तो ये वाला मेंबर 0 हो जाएगा, क्योंकि उसमें अदर मेंबर्स हैं जो वो लोड ले सकते हैं. अगर अदर मेंबर्स हैं तो ये मेंबर जरूरी नहीं है कि वो वहां पे होना जरूरी है. अगर फिर भी कोई आपको डाउट है तो एक बार इसका कंप्लीट आप जॉइंट एनालिसिस करो मेथड ऑफ जॉइंट से, तब आपको समझ में आएगा कि यहाँ पे वो 0 नहीं आएगा.
ओके सर.
ओके, so I think it is fine. Let's solve this. So I will write here that total number of null member forces will be equal to 10. So now let's move to another question. We have two more questions. First is this. In this, it is mentioned for you that you have to calculate forces in member AF and DE. Okay. So what are the members? These are the members AF and this is DE. Okay. So how you will solve? Same method. Start with calculating the reactions. So you have RA here, HA here, and RC here. Okay. Take summation of forces in horizontal direction equal to 0. So what you will get? So you will get HA plus 30 equal to 0. That means your HA is equal to minus 30 kilonewton. Similarly, we'll take summation of vertical forces equal to 0 at A. So that will give you R, not A, summation of vertical forces equal to 0. That will give you RA plus RB equal to 25. Now we have to determine RA and RC, not RB, it is RC. So how we will determine? Take moment about joint A equal to 0. So you will get, take clockwise moment as positive. So what you will get? 25 into 4 plus 30 into this member length. So how you will calculate this length? This is also important. So first see tan, I will write it at the side. So you have tan 60 equal to this length upon this length or up to this length. Fine. So that means x, suppose I'm taking it as x. So this will become half of this length. That will become equal to 2. This will give you, so what is tan 60? It is root 3 equal to x upon 2. That will give you x equal to 2 root 3. That means your x is equal to 3.464 meter. Okay. So your x here is 3.464 meter. Now let's calculate. So we have 30 into 3.464. It will be equal to, I will write minus RC into 8 equal to 0. This will give you RC equal to 25.49. Now let's find out RA. So you have RA plus RC equal to 25. That will give you RA equal to minus 0.49 kilonewton. Okay. Now we will start from joint A. So taking joint A, you have this is joint A. this is become FAF. This point will become FAB. You have angle as 60 and your reaction is 0.49 kilonewton. Now take here summation of vertical force is equal to 0. So if we take summation of vertical force is equal to 0, it will give you FAF sine 60 minus 0.49 equal to 0. This will give you FAF equal to 0.49 divided by sine 60. From this, you got FAF, what you got at as 0.5658 kilonewton. This is the first force you have to determine. Fine. Now we will calculate another force also here using summation of horizontal force is equal to 0. That will become FAB plus FAF cos 60 equal to 0. Okay. This will give you FAB equal to minus 2629 kilonewton. Now we have to determine another force member also, that is FED. So we have to reach till point D. So how we will do? We will start with joint F. Okay. Now we will do for joint F. Taking joint F, draw the free body diagram of this. So this is your F joint. This will become FFE. This will become FFB. This will become FFA. Now draw the vertical line here to show the angle. Okay. So what will be the angle in this? So that is 60. So this will become 30. Fine. This will become 30. So if this is 30, another angle will become 60. Oh, sorry, 30. This will also become 30. And this will become 60. Okay. So now start solving this. Again, take here summation of vertical forces to be equal to 0. This will give you FAF cos 30 plus FFB cos 30 equal to 0. That will give you FAB to be, sorry, F AF to be equal to minus FFB. Okay. Now AF we have already calculated. That is 0.5658. That means your FFB will become minus 0.5658 kilonewton. Okay, fine. Now take summation of horizontal force is equal to 0. That will give you, so horizontal force starts with 30 plus FFE plus FFB sine 30 plus, sorry, minus FFA sine 30 to be equal to 0. Okay. Now in this, you new FFE you have to calculate. You know FFP and FFA. Okay. You know the two values. The third value we can now calculate. So this implies your FFE will become 0.5658 minus 30. It will give you minus 29.5 kilo Newton. Fine. FAF you have calculated earlier. Yes. So what is the value? That is 0.5658. Now FFE now you have calculated, and FFB you have calculated earlier. That will be equal to minus 0.5658. Yeah, anyone has any query? Someone raise the hand. Charuta Patil.
Yes, sir. Yes, sir.
Yes, tell me.
So I have one doubt. When we resolve the forces for by taking joint A
Mm-hmm.
in summation of F of that means in horizontal forces,
Okay,
we can't consider the HA reaction which is given by the hinge support there. So
just a second. Okay, sorry, we have not considered that. Okay, fine, fine, fine. So this is a mistake. I will calculate that. Okay, sorry. Thank you. So that means one more reaction will come into picture. That is this 30 kilonewton. Fine now?
yes, sir.
Okay. So in this case, your FAB will become equal to 30 kilonewton. So this will give you the final answer as 30 minus 0.5658 cos 60 equal to 29.71. Fine. Is it correct now?
Yes, sir.
Okay. So now let's move further. We have FAF. We have calculated it as FBF equal to 0.5678 in negative direction. And how it will come out? As the negative of FAF. Okay. And another is we have calculated uh, FFE, that is coming out to be minus 29.5 kilonewton. Okay. Now we will take the joint E. Okay. So taking joint E, you will get, draw the free body diagram for this. Again, it is FED, FEF, FEB. So you have vertical force equal to 0. That means your FFFEB will be equal to 0 at joint E, and your taking summation of horizontal force is equal to 0. That will give you FEF minus FED equal to 0. That will give you FED equal to FEF equal to minus 29.5 kilonewton. Okay, fine. So we have one more problem left. So if you want, we can solve right now, or I will give you solution in the PDF. You can tell me right now in what way you want. Either I can solve right now, or you want the solution in the PDF.
Sir, solve.
Okay, thank you so much. We will continue now. Okay, so in this, we can see you have to determine the forces in the member, that is member JK and DQ. Okay, so where is JK? JK is here in between, and we have DQ that is also in between. So one thing, if you try to use method of sections, so what you will get? So if you try to divide the section, you will get four forces in this member. One is this. I think you know how to use the method of sections. So if we cut the if you cut the truss into two parts, only the smaller part you have to take, and then you have to solve the problem. Okay. In this case, I am directly giving you the answer. In this, you will get four forces, which will be FJK, FQK, FQR, and FCD. But the point is, in case of method of sections, you have to make the section in such a manner that your two forces will become equal to zero, and only one unknown will come into picture, and that's only you can calculate the unknown forces. But in this case, what is happening, if you take moment about point k equal to zero, you will get this force and this force eliminated, but this force and this force will remain. Second thing, if you see, if you take moment about point d equal to zero, then this force and this force will be eliminated, and this force and this force will be remaining. So that means every time you have two forces unknown present in the equation, that means you can't be able to solve this problem related to using method of section. Now, how we will solve this problem? We will again use method of joints to solve this problem. Okay. So let's start solving this problem. So in this, we got the reactions as RB, and this is RH. Here, horizontal force will also come into picture. That is 25. Sorry, I will not write like that. I will write it as HB. Fine. Now take summation of horizontal force equal to 0. That will give you HB minus 25 equal to 0. That will give you HB equal to 25 kilonewton. Now, taking summation of vertical force is equal to 0, you will get RB plus RH to be equal to 40 plus 25 equal to 65. Now I am taking moment about point B to be equal to 0. Now taking all the clockwise moment to be positive and anti-clockwise moment to be negative, what I will get? I will get as 25 into 2 plus 40 into 6. It will be it will be minus of RH into, what is the distance between them? It is 12 plus 25, this horizontal reaction. It will give you 25 into 3 equal to 0. From this, calculate RH. It will be equal to 50 plus 240. Oh, this is also negative, no? Anti-clockwise. Minus 75 divided by 12. From this, you will get RH equal to 17.92 kilonewton. Fine. Now, calculate RB. So, your RB plus RH is equal to 65. That will give you RB equal to 47.08 kilonewton. So how we'll solve this problem? We'll take each and every joint and then try to resolve the section. So let's make this problem easy. First, determine the null forces. So if you take joint A, you can see there are no reactions. Two members are there. So because of this, this member will be equal to 0. So this member will be equal to 0. This member will be equal to 0. Again, if you take joint I, by that member IP and member IJ will become equal to 0. Okay. Now your problem is simplified. Okay. Now we will solve for rest of the joints. So starting with joint B. So take joint B. What you will get? So this is your joint B. This is your FBP, FBC, and horizontal reaction is also there. So I will make it in different direction. So this is your 25 kilonewton, and your vertical reactions come out to be RB equal to 47.08 kilonewton. Okay. So your FBP will become minus 47.08 kilonewton, and your FBC will become minus 25 kilonewton. Now joint B is analyzed. Now we will move to joint P. Okay. So now taking joint P, we have four forces. This is your force PB. This is your force IP that already become equal to 0. Now you have force PJ and force PQ. Now first you require to calculate this angle theta. Okay. So what will be this angle? You can see from the diagram. So your tan theta will become equal to JQ upon PQ. Your JQ is 1.5, PQ is 2. That means theta will be tan inverse 1.5 by 2. That will give you theta equal to 36.87 degree. Now we know the theta. Now let's solve the problem. Okay. taking summation of what happened. Summation of horizontal force to be equal to 0, what you will get? You will get F Pj cos theta plus FPC. Why I write Q? This will be C now. FPC cos theta if this is theta, this will also be theta. How it will be? I will tell you. This is theta. Suppose I took it like theta. If this is theta, then this also will be theta. Okay. So it will be equal to 0. This will give you FPJ to be equal to minus of FPC. Now we will utilize summation of vertical force to be equal to 0. That will be equal to FJP or FPJ sine theta minus FPB minus FPC sine theta to be equal to 0. Okay. Now we already know FPJ is equal to FPC. We can write twice of FPJ sine theta will be equal to FPB. That will give you FPJ to be equal to FPB upon 2 sine theta. Okay. Now substitute the value of FPB. You have FPB already calculated. Okay. How you got the value of FPB? So you got the value of FPB equal to 47.08 in negative. So minus 47.08 divided by twice of sine theta. You will get the value of FPJ equal to minus 39.233 kilonewton. Okay. This implies FPC will become negative of this. This will give you 39.233 kilonewton. Now, next joint we have to see is joint J. Okay. Now, taking joint J, draw the FBD of this. What you will get? This. So if this is J, you will get Fij that you already calculated to be equal to 0. This will be Fjk. This will be Fjq. And this will be Fjp. Fjp you have already calculated as minus 39.233. Okay. So if that was theta, this will become theta. So this angle will become equal to theta. Now solve this problem. So what you will get, taking, now I will write here, taking summation of horizontal force to be equal to 0, you will get Fjp cos theta minus plus Fjk equal to 0. This will give you your first force that is required, that is Fjk, to be equal to Fjp cos theta. So substitute the value of Jp and cos theta. you will get FJK equal to minus 31.3866 kilonewton. Okay, so first force now we have calculated. Now we have to calculate another force member, that is, I think, dq. Yeah, dq. Now calculate the vertical force. So summation of vertical force to be equal to 0, you will get fjp plus sine theta. I will copy this diagram again for you. fjp sine theta plus fjq, it will be equal to 0. Now you can calculate fjq. It will come out as 18.832 kilonewton. Okay. Now from this, we will move to joint C, because directly we can't move to joint Q, because in joint Q, there are three unknown forces, but we have only two equations. So we will first move to joint C. From there, that we will calculate one force member, that is FCQ. Then we will move to joint Q. So taking joint C, so your FBD for joint C will become this is 25 kilonewton. If this is joint C, it will become FCD. This will become FCQ. This is FCP, and this is FCB. Okay. Angle we have already calculated. If that is 30 theta, that means if this is theta, then that means your this angle also is theta. We have told you earlier. So this angle will be theta. Okay. Now take summation of vertical forces to be equal to 0. This will give you FCQ plus FCP sine theta to be equal to 25. From this, if you calculate FCQ, it will become 25 minus FCP, you have already calculated, equal to 39.233. 39.233 sine theta. This will give you FCQ equal to 1.460143 kilonewton. Fine. Now we have calculated FCQ. Now we can move to joint joint Q. So now taking joint Q, I think I will move to next page. That will be good. I will copy this image. So taking joint Q, draw the FBD of this. So you have four forces here, out of which two you have already calculated. So if this is Q, this is FJQ, this is FQC, this is FQD, this would be FQK. Okay. Let's see. This angle is theta, and this is also theta. Okay. Now we'll write summation of horizontal forces equal to 0. That will give you FQK cos theta plus f qd cos theta to be equal to 0. That will give you fqd equal to minus fqk. Now, how you will determine another force? Using summation of vertical force to be equal to 0. That will give you summation of f jq plus f qk sine theta minus f qd sine theta minus f qc to be equal to 0. F jq you already have calculated. What is the value of f jq? It is 18.832. F qk you have to calculate, and f qd. So I will write it as 2 f qd sine theta. FQC we have already calculated, that is 1.460143, that is minus 1.460143 equal to 0. This will give you FQD to be equal to 17.371857 divided by 2, and it will be equal to 14.4765 kilonewton. Okay. So now both the forces you have calculated. This force is tensile, and another force that you have calculated, that is FJQ, it is compressive. Now I think you know how to solve the complex trusses also, because this is one of the complex truss to solve. And from this question also you have came to know that in which places you have to utilize method of joints and in which place you have to utilize method of sections. So in this case you can see you can't be able to utilize method of sections. So what we can do, we have to utilize only method of joint to solve the problem. And we have simplified the problem by first removing the zero force members and then seeing the problem that in what joints what forces we require. Then only we have proceeded and determine the member forces jk and dq. I think by this it is enough for you for today. If anyone has any doubt, they can ask right now. I will wait for 2 minutes. Does anyone has any doubts? So what we have covered today is to first determine the degree of indeterminacy in different types of trusses, and we have seen how to determine the stability of the truss. It should not always be based upon the degree of static indeterminacy. Sometimes we have to see whether if we apply the load, the truss will remain stable at that particular location or not. That also we have to see. Then we have solved multiple problems related to method of joints. We have seen how the complexity of each problem increases with each question we have solved. And we have solved, I think, 4 to 5 questions related to that. And if anyone has any doubt, they can write in the discussion forum provided to you by NPTEL. There also we can solve the problems, while the rest for this current session The link of the YouTube session as well as the link of this PDF will be provided to you by NPTEL team. You can see the video lecture and try to solve your queries before submitting assignment 2. Okay. I think this is enough for you, everyone. So let's wrap up this session. Thank you, everyone. Have a nice day. Enjoy your weekend.
Thank you, sir.
Yeah, Subhajit Tripathi, you have any doubt?
Sir, please assignment 1 तो resolution provide
Okay.
करोगे सर?
टीम आपको आई थिंक मुझे लगता है इसी वीक में आपको दे देगी.
सर 5 फरवरी तो असाइनमेंट का फाइनल सबमिशन डेट है सर.
उससे पहले आंसर नहीं मिलेंगे ना आपको.
हाँ.
आंसर्स आपको असाइनमेंट सबमिशन करने के बाद ही मिलेंगे, तभी तो आपका असेसमेंट हो पाएगा ना. उससे पहले आंसर्स दे दिए तो फिर आपका असेसमेंट लेने का मतलब क्या रहा. जब आप सबमिट करोगे उसके बाद ही आपको आंसर्स मिलेंगे. सो दिस इज फॉर एवरीवन दैट answers for the assignments will be released only after the submission of the assignments from your side. After you submit the assignment before the due date or on the due date, within 1 week or I think 3-4 days, the NPTEL team will release the answers or answer key related to that, and they will also give you scores for this particular assignment that you have submitted. You can see where you went wrong and then try to solve your errors.
सर
Yes.
सर जो असाइनमेंट है वो वेबसाइट पे है, तो सर वो एमसीक्यू के फॉर्मेट में है, तो बस उसी में सर एबीसीडी के फॉर्मेट में है, तो बस सिलेक्ट करके और सेंड करना है ना सर.
हाँ करेक्ट, और कुछ नहीं करना. आप तो बस सॉल्व आप तो रफ शीट्स पे करना है, बट आंसर आप डायरेक्टली हाँ
जी
आंसर आप डायरेक्टली सेलेक्ट करके वहां पे उसको सबमिट करना है.
सर उसमें वीक 1 और वीक 2 दोनों का असाइनमेंट है, तो सर दोनों को 5 ऐप से पहले सबमिट करना है ना.
वो ड्यू डेट मेंशन होता है ना वहां पे, जिसका ड्यू डेट जब है उसको तभी सबमिट करना है. एक्चुअली अभी मैं देख नहीं सकता क्योंकि मुझे याद नहीं है उसका ड्यू डेट कब है, बट आपको ड्यू डेट के हिसाब से ही सबमिट करना पड़ेगा. ओके.
मैंने वीक 1 का तो सर वो कर लिया है, बस एक लास्ट क्वेश्चन बचा हुआ है.
ओके, आपके पास 4 दिन है अभी, वो 5th of February तक है टाइम उसके लिए.
जी सर.
ओके,
थैंक यू
Hello,
सर.
sir. Can the discussion be in English so that I will understand?
sorry, can you please explain again, tell me.
Well, I'm saying that the discussion, can it be in English so that I can also understand?
Yeah, I am trying to make every discussion to be English, but there are some students who are not actually able to understand. I am repeating the same. I am repeating the same taught whatever I am telling them in English also. So what I am telling them, so what they are asking, that they are asking about the due date of the exam of the submission. So the due date of the submission is for different assignments is different, and they are asking regarding can they get solutions before due date, but this is not possible.
Yes, yeah.
Yeah, you will get solutions only after the
submission. Yeah.
Okay,
Thank
so
you.
this is okay. From the next time, I will take care that I will, if they are asking in different language, I will try to give the answer in both the languages so that others also can understand.
All right, thank you. I'm grateful.
Sir, after submission the assignment, तो जो सर वो जो आंसर जो मिलेगा तो सबमिट होने के बाद तो आंसर को ब्रीफली आंसर मिलेगा ना, ओनली तो एमसीक्यू का जो आंसर था वही मिलेगा पर्टिकुलर क्वेश्चंस के बेसिस पे.
आपको पर्टिकुलर क्वेश्चंस के बेस पे आंसर मिलेगा ना, हर क्वेश्चन का आपको एक आंसर मिलेगा.
अच्छा,
मतलब आप क्या कहना चाहते हो?
मतलब ओनली आंसर मिलेगा ना, ओनली तो मैथ के सॉल्यूशन
मतलब आप कहना चाहते हो कि आपको डायरेक्टली सिर्फ ऑप्शन मिलेगा या पूरा सॉल्यूशन मिलेगा?
हाँ, जी.
वो डिपेंड करता है टीचर टू टीचर, प्रोफेसर. किसी असाइनमेंट्स का वो आपको पूरा सॉल्यूशन देंगे, जिनका वो लगता है कि आप नहीं आसानी से कर सकते हो उनका वो आपको सिर्फ ऑप्शन भी दे सकते हैं. अगर आपको लगता है कि नहीं आपको नहीं समझ आ रहा, आप उसमें क्वेरी भी डाल सकते हो.
Okay, okay, okay.
Okay.
Thank you, sir.
Okay. So I will repeat again what he's trying to ask. He's trying to ask like, will he get the complete solution regarding the assignment what they are submitting? So what my answer is that it depends upon the assignment to assignment and the professor. The assignment which he feels that it is easy to solve for them, he can only give the options, not the complete solutions. But for the assignments which are more complex, they will give you complete solution regarding that. And if you find that the solution is not provided to particular question in that assignment, you can ask in the query that I am not able to get the answer, can you please provide me the complete solution? Then definitely they will give you the complete solution. I think this will cover your query.
All right. Thank
Okay,
you.
sir. Thank you.
Okay. So does anyone has any other query regarding this?
No, sir.
Okay. So let's wrap up this session. This session
Yes, sir.
went too long. So let's
Yes, sir.
meet on next Saturday. We will solve the problem related to deflections using we will try to determine the deflection in beams. Okay, using method of virtual world. Or which method is there? I don't know. I have to see again. So next week we will solve the problems related to deflection using virtual world. So from using virtual world, we will solve the problems related to determining the deflection in trusses. So thank you everyone. Have a nice day. Enjoy your
Thank
weekend
you,
also.
sir. Thank you, sir.
Thank you.
Okay.